The first thing we want to do today is look at the construction of the stickman. The stickman you see before you is non-metallic. There are no metallic screws or pieces on this stickman. It's PVC plastic using plastic threads to hold the probe in place. That's very important to note. The orientation of the probe is also very important. At 27.6 megahertz, which the heat sealer operates at, it's important to have the probe on a horizontal orientation. A vertical orientation will not pick up your radio frequencies at 27.6 megahertz. Another important thing to note beyond the stickman is the different markings that we've got set up here representing the different areas of the body. So we have the head, the neck, the chest, the waist, the groin, thigh, knee, calf, and ankle. All those are outlined in our SHIA policy for RF measurements. So again, no metal, all plastic or wood, your probe must be horizontal, and your body parts need to be marked according to our policy. Before I begin measuring RF, it's important to note, remove all your cell phones. Cell phones will interfere with the measurement and will artificially raise your measurements higher. So I'm going to remove my cell phone. We'd like to take a moment to review the construction of the stickman. A properly constructed stickman is made of plastic or wood. No metal can be used in the construction of the stickman. In this case, our stickman is made of PVC. It's situated such that the probe from the meter is horizontal, not vertical. That's very important. At 27.6 megahertz, we must have our probe, our measuring probe, horizontal to the floor. Another thing that you'll notice on our stickman is that we have the set heights established on the pole so we know where the probe height should be as we take our measurements. All right, I want to take a moment. At the present time, our probe is at the groin. And I want to point out to two key areas that you should be aware of. That is covered in our training, but I want to emphasize it. The groin and the head. The threat of RF is internal body heating. But the body is a great radiator. It can regulate body heat very well, except in two areas, the eyes, and for the men, the testes. And the reason being is that there isn't very many blood vessels in our eyes, or testes, therefore it cannot regulate the heat. As such, we're very sensitive as to what the electrical and magnetic heating reading is in these particular areas. Why? Again, because we cannot regulate the heat out of those areas, and therefore we can do some internal damage due to internal temperature rise. All right, we'd like to demonstrate how to take cycle time. So in front of you, you're seeing my stopwatch that I use to record the cycle time. And in the background is the ceiling head that I'm going to time. In this case, what I'm going to do is I'm going to start the stopwatch when the ceiling head first comes down and makes contact with the guarding. That'll be the beginning of the cycle. At the end of the cycle, it's when the next platen rotates into position and the ceiling head again makes contact with that guard. Here we go. Okay, at this time we'd like to demonstrate how to record and measure the cycle time of a piece of equipment. As you can see, I have a stopwatch to record the cycle time, and in the background is the ceiling head for this RF piece of equipment. What I'm going to do is I'm going to start the stopwatch when the ceiling head first comes down. As the machine rotates into the next position, I'll stop the stopwatch again when it first makes contact with the guard. That is the cycle time. So in this case, our cycle time is 10.44 seconds for a single cycle. Next, we'd like to demonstrate proper measuring techniques for RF. First, I want to make sure the stick man and the probe are in the proper position. In this case, we are 6 inches from the guarding. We've got our probe horizontal. Before I take measurements, I want to make sure that I remove the cell phone. Any cell phones or fluorescent lamps that are close by will interfere with your RF signals and either artificially inflate or artificially lower your measurements. The first measurement will always be at the ankle. That's your lowest setting. We'll always do the electrical first, then go to the magnetic. What I'll do is I'll start measuring my electrical readings at the ankle and move up my stick man, and then repeat the process on the magnetic mode. The reason we do that is at 27.6 megahertz, which is what a heat sealer operates at, the electric poses a bigger threat than the magnetic. So we want to make sure that we're safe as we're taking our measurements. So I've got my meter set on electric. I put it over slightly so it doesn't interfere or reflect any signals back to its probe, and I myself will stand aside. If I stand in this present position, any RF signals will come to me, reflect back to the probe, and give you artificially high numbers. So we'll let this RF piece of equipment cycle through a full rotation of the table. Once that is done, I'll take the peak reading. I'll record that reading. Once I have it recorded, I'll reset the meter to 0, and I'll move it up to the next location, which in this case is the calf. Reset my meter. Okay, now I'm ready to take a measurement at the calf height. Again, after the table of the RF machine has been full rotation, I'll record that max reading before I move up to the next height, which is the knee. I'll continue doing this process until I've made it all the way up to the head, recording the max reading at each level. Once that is done, I'll reset my meter, I'll put on magnetic, and I'll go back to the ankle and start all over again. Important things to note: position of the probe is horizontal. If you're wearing a cell phone, make sure it's off. Don't have any fluorescent lamps around. That's going to artificially raise or lower your readings. Notice I'm off to the side. I'm not behind the probe because I do not want to interfere with the wavelengths, either reflecting or absorbing into my body rather than being measured by the probe. Okay? Okay, so we're finishing up the last measurement for the electric. So again, we started at the ankle and went up to every one of the incremental heights established in our RF procedures. I'm at the head. Again, remember, sensitivity to the eyes, inability to regulate body heat. So I'll let the table take a full cycle. Once it's done, I'll take the peak measurement. Now what I'll do is, again, I'll go back to the ankle and repeat the process in the magnetic mode. So again, down to the ankle. I'll reprogram my meter to read magnetic, reset the value, and I'll start the process all over again. Putting the meter to the side, get out of the way. And again, we repeat the process. Typically, the position of the stickman is such that it's in the location where an operator is. For this piece of equipment, a Forcon, the operator really doesn't stand close to the RF ceiling table. But we've identified the area that most likely will experience RF wave leakage, and that is on the back side here at the gap between the guarding. On this piece of equipment, the operator actually is positioned multiple feet away from the RF table. But we take a measurement here just to ensure that there is no RF wave leakage. On this piece of equipment, as I said earlier, the operator is actually standing away from the RF ceiling table. But here's his normal position. So typically we would also measure where the operator resides. So in this case I'm going to put an X on the floor to indicate where we'll put our probe and our stickman. The X on the floor is where the head of my probe will be above. recording the cycle time, we also record the heat time. For the heat time, we actually go into the controller that controls the welding process of the RF equipment. And as laid out here, the welding parameters are listed out. The welding time that we will use in our spreadsheet is 3.7 seconds, as demonstrated by our controller. So physically, we record the cycle time using a stopwatch and visual cues, but for the welding time, we really can't say when the welding head is receiving electrical current, so we need to go to the controller to determine what the operation is set up as.